Hello, everyone. Our next speaker will be Anthony Scopatz, and he will be speaking to us about a new command line shell that you might be interested in. So please join me in welcoming Anthony. Thank you.
All right. Hello, everyone. I'm Anthony Scopatz, and this is Xonsh. So, what is Xonsh? Xonsh is meant as a general-purpose shell language to replace things like Bash or Fish or Z shell. But it also is simultaneously a Python superset language. And some of the features of this are that we have no external dependencies other than the Python library, Python itself. And so if you have Python, you also have the ability to have Xonsh. And because of that, we support the big three major platforms, Linux, Mac, and Windows. And sort of the purpose of Xonsh, at least in my mind, is to trick scientists and engineers into being more reproducible, but I don't have time to go into that into this talk, so you'll just have to talk to me about that later. And there's a lot of fancy features, especially if you're willing to install some other code, and we'll see some of that in this talk. But before that, I just wanted to give some motivating examples between Bash and other SH languages and what we have available in Python. So here's a simple example of a for loop, right? In an SH-based language, you have to do a little more for a for loop. Not a big deal. Our Python version we all know and love. How do I screen this? Okay. Yeah, okay. Well, I can do this maybe. All right. No. All right. If they promise me something. There we go. Yes, no. All right. Yeah, there is no other resolution that works. So that works. Okay. All right. Well, we'll go from here. All right. All right. Sorry. The best laid technical plans. Woo. All right. Live debugging. This is what we're all about. So another terrible Bash example is testing whether a file exists, right? There's a beautiful Python API for doing this. And in shell-based or in SH-based languages, there's a lot of syntax and some weird commands, and they overlap with a bunch of other syntax, and it's hard to keep straight. And you almost always have to look this up. And the last example is just tokenizing a string by a non-white space character. In Python, this is super easy. And in shell-based languages, you have to set global state and then reset it back after you're done tokenizing the string. It's an absolute disaster. Okay, so you're all motivated right now. So the stages of Xonsh development sort of went as follows. There was this initial conceptualization stage where, this situation cannot stand. So what if you had the ability to take the best parts of Python and the best parts of Bash or some other language? And then that inevitably led into actually looking up how to do this, researching things like Ply and other parser libraries out there, and coming to the realization that maybe it actually can't be that hard, right? So, and that inevitably, once you have all the pieces in your toolbox and you know how to do it, and you see the way to do it, you go ahead and you feel that you must build this library. And that's kind of where we are at emotionally with Xonsh right now. And the following stages of anger, regret, and acceptance are sure to follow any day now. So without further ado, let's actually dive into what the language actually looks like in some examples. So this is best done in a demo, so prepare yourself for some really fast typing here. All right, so the first thing you'll notice about Xonsh is that it's really meant to be used as a general purpose shell, so the prompt looks like what you would see in other languages, right? It has the who you are and where you are in the file system, etc. But on the other hand, it really is Python, so you can do things like add two numbers together, what a novelty. Or you can import modules, that's kind of nice, and access members of that module. Okay, I'm all messed up here. Sorry. The re-res messed me up. Or you can create dictionary literals and access members of those dictionary literals, or do more complex statements like if statements, etc., or for loops or while loops, or define functions in your current execution context, and then go ahead and call those functions, right? In some very real sense, Xonsh is Python. and it's all, but it's a little more than Python because we add a bunch of shell-like primitives to the Python language. So for instance, we add a $ operator that works like it would in Bash, where it looks up variable names in the environment. And this is very similar, but the difference here is that we're able to go ahead and set variables like you would in Python, set environment variables like you would in Python, and then access those from subprocess commands like you would in Bash. So Xonsh keeps a very clear notion of whether you're in Python mode or subprocess mode, and we'll talk more about this in the coming slides. But you can access and modify the environment in a sort of more Pythonic way. And additionally, because it's Python, things like your path are really a list of strings, right? They're not some crazy colon-separated list of strings. And this works for any type. You can have any structure. You can have your own custom class that you stick an instance of into your environment and then access it that way. So, okay. So that's easy peasy. Additionally, we add a $ curly brace operator, and what this does, it's distinct from the same operator in Bash. So here we look up the environment variable based on an expression that's been evaluated inside of the curly braces. And so you can use this to programmatically look up variables if that's something that you want to do. And of course, all of this stuff is available in subprocess mode as well, so you can echo tilde cows come home. Additionally, if you look up in ellipsis, so if you do $ curly brace .. and curly brace, this is a reference to the environment itself. And so you're able to do things like test for containment or access methods of the environment just by using $ curly brace ellipsis. Okay. Moving right along, it wouldn't be a very good shell if you couldn't change directories. So here we've just changed directory into the Xonsh repository. And as you see, when you do that, the branch name pops up appropriately colored. This works with both Mercurial and Git. And so it's really sort of a developer-facing tool in that regards. It's meant to have all of these things that you would like and use. Additionally, if we go ahead and type git sta and then hit tab, you'll see that we have this drop-down menu of all the tab completion options that are available. And in particular, this is actually just eating the Bash completions that have already been written. So we don't have to necessarily rewrite all of the completers for all the commands out there. They're just accessible to Xonsh. And this works even on Windows, which is kind of cool. Let's go back to the home directory. And additionally, we have this $ parentheses operator, which does pretty much exactly the same thing that it does in an SH-based language, in that it returns to you the result of a subprocess as a string. No big deal there. Additionally, this is available in both Python mode and subprocess mode, so you can do $ parentheses to subprocess, to capture the subprocess as a Python variable, and then use Python string manipulation to modify that string however you want. And that's just a single expression. Additionally, we also add an exclamation point parentheses operator. And what this does is it returns to you a special completed command object that contains not only the standard out, but all of the metadata about how that command was run and what its results were. And furthermore, we add a exclamation point square bracket operator that does pretty much the same thing, except that it streams the results to you. And then after that, after you have this X, you're able to access things like the timestamp for when the command started and stopped, the alias that the command was run with, and we even implement appropriate Boolean semantics. So we look at the return value of that completed command and test whether it's equal to 0 and return that. Okay. So far what we've seen is subprocess mode in Python mode, but of course Xonsh allows us to go the other way. And so say we have two Python variables here. If we do echo at parentheses, we evaluate what's inside of those parentheses as a Python expression, and then convert that to a string, and then pass that down as a single argument to any subprocess that we want to call. And additionally, this works for anything that's string convertible, so you could echo 2 + 2 and actually get the result that you're interested in. And furthermore, if you pass in a list of expressions, each of those expressions will get sent down to the subprocess as individual arguments in the argument list. And obviously, this stuff is perfectly nestable. And so if you're in Python mode and then you go into subprocess mode, you can go back into Python mode, and everything works out just fine. Moreover, you can use this at parentheses stuff to programmatically determine what command you want to run. Whether or not that's useful or how much obfuscation you like is up to you. But the place where this at parentheses stuff really shines for me is the fact that you can now use normal Python looping semantics to loop over a set of data and then run over subprocess commands very, very easily, like we see in this example here. OK. All right. Next, it wouldn't be a very good shell, of course, if you couldn't pipe things, so we implemented piping. Similarly, it wouldn't be a very good shell if you couldn't redirect things, so redirection to a file or to from standard error to standard out, and all those things are available as well. So, OK. Additionally, we added, by popular demand, the ability to and or subprocesses together using Python's and or keywords. And all this is doing is it's wrapping those subprocess commands in exclamation point square bracket before it runs them. And don't worry if you have a lot of muscle memory and you want to use ampersand, ampersand, and pipe, you're welcome to do so. I won't hold it against you. So, and the place that this is particularly useful is if you want to test if a file exists and that a file doesn't exist, and that another file doesn't exist. If you do that, you'll just get back the appropriate Boolean. So, and this is all, using the normal kind of Python and or and grouping, parentheses groupings and negation semantics that we all know from Python. Additionally, we add a regular expression file globbing using backtick. So anything in the backtick is compiled as a regular expression and then sent down to either the subprocess or it returns a list of strings in Python mode. So we could write more complicated regular expressions. So if initially we were just looking at all the Python files in a directory, but if we wanted to look at all the Python files that didn't include an underscore, that's easy to represent as well. And to just show that this works in Python mode, we can go ahead and take the length of that regular expression. OK. Like IPython, we add a question mark operator to give you help on whatever object you ask for help on. No big deal there. We also add a super help operator, so you can do question mark, and what this does is it goes and tries to find the source code that the object was defined with, and in Xonsh, we go ahead and syntax highlight that source code for you as well before we print it. So, OK. Additionally, we have an aliases mapping, right? So this just maps command names to the command that you want to run. Nothing super complex there, except for the fact that we have a few different forms of aliases. So we have the normal list of strings-based aliases that you would see in a bash or in other kinds of shells. But since we're Python, we also have the ability to take functions as aliases. So here, let's just define a little alias that takes a lambda that accepts the standard args, or accepts an argument list and a standard in. And here, we're just going to ignore that and return a string no matter what. You can also return standard error and return code if you desire. And so when we go ahead and run this command on the command line, we just get that string printed out. But this, so maybe doing something a little more interesting, if we create another lambda that actually reads from standard in and maybe formats a string using Python string formatting, and then returns that result. So here, once we have this set up, we can go ahead and echo a name and then pipe that to our new alias, and we see the ominous message that we would expect. OK. All right. Additionally, Xonsh has a very well-defined notion of what it means to be a foreign shell. And so just as an example here, here's a little bash script called owl.sh that does a few different things. So the first thing that it does is it exports an environment variable, it defines an alias, and it also defines a bash function. Now in Conch, we add a source bash command that allows you to source this bash file in exactly the same way that you would source it in bash. And so if we look, we can see that this environment variable is loaded into the Conch environment when we source that file. Additionally, we get the alias, as you would expect. And we can even call this bash function in exactly the same way that you would call it in bash. And this all just works. And so this is implemented currently for bash, Z-shell, and command.exe. And clearly, there's still a big fish in the room here. So. Of course, another thing that would make Conch not be a very good language is if it didn't have a file format. So here we are showing just that same owl.sh script written in the .xsh conch format. And additionally, we've added a Python function that times a ping command and then returns the result. So if you go ahead and source owl.xsh, you get that time ping command loaded into your current Python context, and it runs just fine. Additionally, Conch also has import hooks for any .xsh file, so you can go ahead, and those are easy to load thanks to Brett Cannon and other people. And you can just, if you prefer to import owl and then do owl.timeping, you're welcome to run code that way. Okay. It's worth mentioning that Conch has a very rich and detailed notion of what history is that I don't have time to go into here. So you're just going to have to look up the docs on your own or talk to me afterwards. And this was kind of put in there for some of these reproducibility concerns that I mentioned before. Okay. That all being said, Conch, the purpose of that was to show you that Conch really is Python, but it also is meant to be used as a general purpose shell, and so there's a more detailed translation guide on the website that you're welcome to check out. And how does all of this stuff work? Well, it works like most languages work, so we go through a number of common phases. So we have a tokenizer, a lexer, a parser, compilation, and execution stages. But the thing that's different is that Conch inserts this syntax tree transformation phase. And this is super important. So just to go through these one by one, the tokenizer and lexer are a little more complicated than you would think because Conch has to keep track at a very deep level of whether it thinks you're in Python mode or in subprocess mode. So Python is not white space sensitive inside of an expression. So the three ls-l examples up here all compile to the exact same Python code. However, subprocess mode is exactly white space sensitive. So these three ls-l expressions up here compile to three distinct pieces of code and have different representations and would do different things. So we need some way of resolving the ambiguity between Python's white space insensitiveness and subprocess's white space sensitive aspects, which we'll get to in a couple slides. The parser is written in Ply, and what the parser does is it produces a syntax tree of normal Python AST nodes. And so when I say Conch is Python, it actually does produce the same exact syntax tree that if you called ast.parse, you would get from the Python standard library. And this is really useful because we can just hand that syntax tree off to functions like exec and compile, and it's then the Python interpreter's job, and we don't have to care about it anymore. And to make all this work, we shove a bunch of things into built-ins, so to us. Okay. So the syntax tree transformation phase is really here to resolve this ls-l ambiguity. And so this has two subphases. It has a first phase, which is context insensitive, and then the second phase, which is context sensitive. And so to keep this clear, we've reduced this to just a couple simple rules for what it means to do context-sensitive parsing so that you can gain an intuition about how a command's going to work or when it's going to run. So if the rules are basically if the leftmost name is not in the Python context or Python scope, and that expression as a whole can be parsed in subprocess mode, so if the ls is not a Python variable, basically, then we'll go ahead and wrap it in exclamation point square bracket. And if the leftmost name is in the Python scope, then Python always wins, and we parse it as Python. And if it doesn't compile with either Python mode or in subprocess mode, then it's a syntax error, and we raise it as such. And if you want to avoid this, you're welcome to always type exclamation point square bracket. It's your fingers. So. Compilation and execution, nothing new and special here. So we just hand it off to the Python interpreter. So that being said, I wanted to show you some more intense examples about sort of the things that you can do with Xonsh now that you have this language available. So here's a ridiculous way to, really obfuscated way of typing ls-l using all the Xonsh syntax. Sort of a silly example. I guess my thing is lost here. But another motivating piece is that you have the full Python library, you have all the Python ecosystem and libraries available to you, and you can directly pipe things. Well, I'm going to have to make this a little bigger, I'm sorry. Yeah, so sorry if it gets cut off. Oops. So you can directly pipe things from the internet. So say you wanted to go grab the conch license, you can take NLTK and pass the result directly into NLTK and get the first 7 sentences or so as a list, just as a single Python expression. Okay. Oh wow, this is also useful in, wow, this is not working out, I'm sorry. Yeah. Sorry if it gets cut off. So you can also use this to grab say you have some JSON API from the internet and you want to go grab that, you can use curl to grab that from the internet and then directly pass that into json.loads and use that to format a string. So if you deal with a lot of JSON APIs, this is all done as a potentially single expression, and it'll print you that message right away. So that's something cool that can be done. Additionally, Xonsh has a very well-developed notion of colors and color management. And so this was put in for a couple of reasons, like perhaps you're on a terrible system with really bad color styles, but also sort of the more important aspect is for people who may be colorblind, this is really helpful because you are able to they're able to select a color palette that works for them. All right, so finishing up here, while I'm on the subject of colors, I'm just going to jump ahead here. If you import NumPy and matplotlib, we have a third-party extension system that we have written hooks for matplotlib in, and will allow you to just dump out the current figure as via background colors. So, bam. If you like really pixelated graphics, I guess. Just to finish up, we believe that Xonsh is a usable tool right now as a shell. There's obviously more to do. We're at version 0.3.2. Please, we love to have a community of users and contributors. So please, try it out and let us know how you feel. And just remember that a vote for the shell in 2015 yields Xonsh in 2016. Thank you very much.
Thank you very much, Anthony. We do have time for some questions, so there are 2 microphones on either side of the room. Please feel free to line up, and Anthony can answer. We'll start on this side.
Hey, great talk. I think I'm looking at my new shell. But one question, is there the prompt command?
The prompt command, like
yeah, so like every time you hit enter, it can run a command as it, to create your prompt?
Yeah, so we
like PS1 command.
Yeah. So you can mod. There's actually a prompt environment variable that you can totally customize and modify, and this is all in the docs. And so yeah.
Okay, so as I go, it can.
Yeah,
update.
it's just called $prompt, and there's huge documentation on how you color that and what aspects you want. There's even a write prompt if that's something you're interested in. You can customize the multi-line prompt and everything.
Okay, awesome. Thank you.
Thanks.
Oh, thank you. Okay, I've got 2 questions. First, is this a strict superset of Python syntax?
Yes.
And second would be, have you implemented process substitution from Bash and Corn Shell?
Yes to both of those.
Awesome.
Now, the process substitution may be buggy still, but it has been implemented. So, yeah.
So just a quick question on performance compared to other shells. A few words you can say about that?
Yeah, so startup times currently suck, but we're working on that. And they got worse on the last release, sadly, but we know how to fix it. The actual performance of different pieces, so the compilation execution stage is actually relatively quick, and even doing things like tab completing is actually much faster than other shells because we keep in memory sort of all of these components. So in general, the actual execution while you type is not so bad. It's just the startup time that we need to deal with.
Thank you.
Does it work inside a Jupyter notebook?
Yes, it does. We ship stock with a Jupyter notebook hook.
Does Xonsh play nicely with virtual envs?
Yeah, it does, and we also have a command. So there's been a lot of talk about this, and so worst case scenario, we also ship with some virtual env commands as well. But a lot of the foreign shell interface stuff was actually motivated by virtual env. Now, virtual env does some ridiculous things, and that makes it difficult. So if you're running into those, we have alternatives for you.
Perfect, thank you.
Amazing product. Why do you think it is that it took us until the year 2016 to get to something like this? And how long do you think it'll be before this becomes standard and then before we can settle on something a little bit less Frankenstein's monster feeling and more just like pure shell awesomeness, which is where this is taking us?
Why do I think it took until 2016? It was that moral compulsion to act, and probably the fact that no one wanted to re-implement the Python language spec, which I did as a stress reliever project while writing a book. So
you're a hero.
And then writing a book can be effective. And then, how long does it take till this becomes standard? Hopefully tonight. Woo.
Yeah, so this is insanely awesome. What's the configuration scheme, and does it work with like bash profiles, bash RC, any of that?
Yeah, actually, so another reason for the foreign shell interface is that by default, it will load your bash profile and everything, but you can set it up to load your profile from any other shell that we have hooks for, or set it up to load profiles from no shell. And so, yeah,
awesome.
We've rounded that out. So.
I noticed when you ran ls earlier, the output was a little bit slow to come through. Is that because of the Chrome extension that you're using, or is that a performance thing?
Oh, this was not live. This was me fake typing.
Yeah,
I was not going to do that live. Did you see that URL for the Weather Underground? Come on.
Thank you.
I was wondering if, in addition to standard libraries, can I install like requests and then suddenly start using requests as part of the command line?
Yes, absolutely. Yeah, anything. It is Python, so anything that you can import in Python, you can import in Xonsh directly and just start using it.
Perfect. Thanks.
Yep.
Hi, I was wondering if you have support for something similar to some of the IPython magic functions, or you can do like debugging and that kind of stuff.
So we don't implement any particular debugger support, although that has been requested, and hopefully someone will do that. The magic function stuff we don't have support for, but my question for the magic stuff is what magics are people interested in, right? So, and then we can talk about how to implement those features specifically.
Do you feel that Python is the best language choice for this, or is it just the one that you happen to like the most at the time?
I do feel that Python is the best language for this because it's a high-level dynamic language, and you can do the syntax-free transformation stuff dynamically. Just the other dynamic languages are out there, like, I don't think there's a good scope. So Ruby is an example. In Ruby, they don't have the same kind of scope and broad ecosystem, and languages like JavaScript, even if you're using Node, they don't have the, they don't really have the OS level things that you would need, right? You can't really manage signals very well. And Python has this beautiful, maybe not beautiful, but functional interface for handling signals. And so, there is another project called Ammonite out there that does something similar for Scala, but I think we're doing a little better than them currently. So.
Seems like an awesome system. Are there reasons I should not switch to Xonsh as the shell I always use?
I don't think so, but if you find them, please report them.
Okay.
Wait, is there time for one? Okay.
Last question, sure, please,
Okay,
thank you.
So how does the, do you have like line editing?
Uh-huh.
So, and is there like a VI mode? Or
Yes,
not yet?
there is VI mode. So this is an important point. We have two backends for line editing. So we use readline with all of its problems and glory. And then we also we use Prompt Toolkit, and both of those have VI modes available, but the interface to that, we don't have a unified interface for, in Conch you can just set VI mode, $VI mode equals true, and then you get VI mode.
Okay.
So, all right.
Okay, let's thank Anthony again. And the next talk will start in this room in about 10 minutes. Thank you.